Hello students, today we learn another uh, important data structure called nonlinear data structure. So last class we have learned about linear data structure and with many examples of linear data structures and what are the operation we can perform with linear data structures. With the case studies we studied all like stacks, queues, their static data structures, and also one more we discussed is a linked list. So on all these data type, the data structures we performed with all that's traversing, searching, insertion, sort, deletion, all we did excluding merging operations with arrays, stacks, queues, linked list, uh, and also we have learned advantages, disadvantages of each linear data structures. So now let us learn something about a non-linear data structure. So what is a non-linear data structure means? Already I have said a linear data structure means a data structure in which the elements are organized using adjacency relationship. So what is non-linear means? As the name suggests, non-linear. So need not be continuous or one after the other. There is no physical adjacency or logical adjacency. So other than adjacency relationship, if you organize data in a computer's, then we call it as a non-linear data structure. So we use some structures where organization of elements is other than adjacency relationship. So maybe it is like parent or child, like hierarchical relationship. So whatever we use, that is called as a non-linear. But there should not be any adjacency relationship, whether it's a physical or it is a logical adjacency, we do not follow. But we have the like hierarchical or maybe a parent-child relationship. Other than adjacency relationship, it is called as a non-linear data structure. So let us learn about non-linear data structure and we'll go with examples. We have trees and graphs. We learn what is tree, how do we represent trees, and what is graph, how do we represent graphs, we learn something. And also how the operations, we're not learning in detail, but when you go for higher studies, you'll be learning like stacks, queues. You also learn about trees like expression representation in fix, postfix. There also you are going to use this trees. Okay, now let us learn about what is a nonlinear data structure. A nonlinear data structure is a data structure in which data item is connected to several other data items so that the given data item has a possibility to reach one or more data items. The data items in a nonlinear data structure represent hierarchical relationship. Each data item is called node. Example of nonlinear data structures are trees and graphs. We learn all these things. So they have, starting with one, it is possible to reach many other data items. Like we have a parent, and then the parent can have many child like this. So there is a many. So starting from one data, it is possible to reach one or more data items. So the data items in a nonlinear data structure represents using what we call hierarchical relationship. So hierarchical, you know, like we'll discuss that one. So this is there are some advantages of nonlinear data structure. Uses memory efficiently as contiguous memory is not required for allocating data items. Whenever we talk about a linear data structure means, so it becomes necessary to represent continuously. The memory should be continuous. We need a consecutive memory location. So as a result, what happens, there is some spaces in between we cannot use. So, but when you use a nonlinear data structure, they do not need a contiguous memory location. Therefore, the memory can be used more efficiently. So normally what happens means, so you can imagine, I'll show you with some example. You can see this. So let me write like this. So this is a computer memory. Okay, computer memory is a sequential. What happened? It looks something different. No problem. Try to understand. So this memory is used. This also used. This also used. But this space is vacant, and this is also used. This also consecutive. It is used. It is used. It is used, and this also free. This much free. This much free, and this also used. Example. And this is also free now. You can take it. This is free. So whatever, now what happens, this space cannot be used for what we call linear data structure, and now this space is also vacant and this space is also vacant. So when you combine this, we'll get more space, the huge space. Now what happens means, because I wanted consecutive, so this memory cannot be used for linear data structure. So when you go for nonlinear data structure, the memory need not be like this continuous. So this part could also be used and this part could also be used because it uses other than adjacency relationship. So then what happens? So the memory is now, actually we use the linear data structure, these memory is of no use because we have to combine these three, then only we can perform some operation because that requires that amount of memory. Now what happens? This alone is not sufficient, this alone is not sufficient, but together we can serve some purpose. Now what happens in linear data structure, this cannot be used. But when you go for nonlinear data structures, they can be used. That is what the advantage is. So uses memory efficiently as a continuous memory is not required for allocating data items. The length of data item is not necessary to be known prior to allocation. Like how much data is, like 20 we need, 100 we need, so it is not like static memory allocation. The length of data items is not necessary to be known. As and when it is required, we keep allocating. That's advantages. So what's the disadvantages means? Overhead of the link to the next data item. So because they are in physically at different locations, to establish this link among them is a complication. That's a disadvantage. Overhead of, that's a drawback of this, the link to the next node, next data item. So where this node is present, where this node, so maintaining that link is a quite difficult in nonlinear data structure. There are some advantages and also there is some disadvantages. Let us learn about trees. What is tree and how it is represented? You can see this is a tree hierarchical relationship where we have a root, we have nodes, we learn all definition one by one. A tree is a data structure consisting of nodes. These are all nodes organized as a hierarchy. You can see a start from this node, all other nodes are organized. That's what hierarchical relationship. So this is very important. Tree is a data structure in which it's a, you can say it's a consisting of or collection of nodes. They are organized using the hierarchical relationship. This is, you can see a hierarchical. From this it starts, then we have like this, we have this, next we have this. So this is a hierarchical relationship. So that is what we call as a tree. Let us learn some terminologies. What is a tree? What are the different words associated with the tree? A node, already we know, in linked list also we know. Node is a structure which may contain a value, a condition, or represents some separate data structure as well. So which could be a tree of its own. So that could be subtree, we'll discuss. So each node in a tree has a 0 or more child nodes. So each node can have 1 or more child, or maybe 0 also, which are below it in the tree. By convention tree, we draw growing from downwards. A node that has a child is called the parent node. A node has at most one parent. So nodes that do not have any children are called leaf nodes. They are also referred as a terminal nodes. We have learned some definitions here. What is leaf node or terminal node, and what is parent node, and then what is a node. So node is a structure which contains a value, condition, or represents separate data structure, which could be a tree of its own. So each node in a tree has a 0 or more child nodes, which are below it in the tree. By convention, trees are drawn growing downwards. So we'll see learn now. A node that has a child is called a parent node, ancestor node or superior node. A node has at most one parent. Every node has at most only one parent. Nodes that do not have any children are called leaf nodes. They are also referred as a terminal nodes. We can see here. So tree is drawn from root to leaf. So this is called a root node, and this is a collection of nodes. And root node may be having one or more child. So this is called child. left child, you can call it a right child, and this becomes a parent node. So parent node, every child node can have a maximum one parent. You can see these are also many child can have this. These are all subtree, what we call nodes. And so what is the parent for this node means? So this is a maximum one parent. This also one parent. So each child can have at most one parent. And parent node can have many child. And the node which has no children is called leaf node or terminal node. That's the end of the tree. So these do not have a children. That is called leaf node. I think you got an idea. So this is something about what is a node, what is a parent node, and what is a child node, and also what is leaf node or terminal nodes. So now let us continue with what is the height of the node. So height of or is the length of the longest downward path to leave from that node. You want to know where exactly the node is corresponds to. What is the length, what is the length of the node, or that is also called what is the height of the node. So suppose we take some node. So how do you decide the height means from that node to the downward path to the leaf node. So that is what we call as a height of the node. So the height of the root is the height of the tree. So because root starts, so the height of the tree means that is the height of the root. The depth of the node is the length of the path to its root path. So for example, you can see the topmost node in a tree is called root node. Already we know about. So being the topmost node, the root node will not have any parents. Yes, of course. It is the node at which operations on tree commonly begins. That's the beginning point. That's a root node. So all other nodes can be reached from it by the following links or edges. So you can see here, so when you see here, this is a root node, this is a topmost node, and it has no parents. So all the operation, all the data items in a tree are reached through the root node. From this we are able to reach, and from this we have to reach all other nodes. It's like a beginning. Through the link we can move from one node to another, but it has to through the root node. And also I told about what is the height of this node and what is the height of the tree. So what is the height or level of the tree means? So from the root to the last node like this. You can take here. So we have a 1, 2, 3. So longest path. So we have to 1, 2, 3, 4. The level or length of the tree is, it is 4 now. So this is the height of the tree. You want the height of this node A means, so from this node longest path. So 1, 2, 3. So this is called the height of the node. So node of order 3, this one, 1, 2, 3. That's height of the tree. This is height of the node. Height of the node means from that node till the last node. So count. So it's a downward path. So we have 1, 2, 3. So this also you can see 1, 2, 3, 4. That is the height of the tree now. So from root to the leaf node is called as a height of the tree. So or depth of the tree we call. So this is something about the height and depth of the tree. So now let us learn what is an inner node or internal node. So inner node is any node of tree that has child nodes and thus it is not a leaf node. So what is a internal node or inner node means? Any node which has a child is called inner node or internal node because it is not a terminal or leaf node. What is subtree means? A subtree is a tree, capital T, if it is a tree, is a tree consisting of a node in T and all of its or descendants in T. So we have some small letter t is a subtree of T means. So all the nodes of this tree are descendant or from the capital T. So that is this tree is called subtree. So that's a simple example. So what is you can see if you take only this much like this, okay, you consider this like this, these three nodes. So this is definitely going to be subtree if the whole tree is an example of capital T and this is going to be subtree. So it is descendant from the main tree. That is what we call as a subtree. So any number of subtrees can have in a given tree. So next we have a binary tree. So I think whenever we talk about binary means something associated with 2. So what is the simplest form of tree is a binary tree. A binary tree is a tree in which each node has at most 2 descendants. A node can have just one, but it cannot have more than 2. A tree which has only 2 subtrees or 2 subnodes maximum, at most maximum we can have 2 subnodes. That is what we call as a binary tree. You cannot have more than 2 nodes. Such trees are called binary trees. So we have in a binary tree consisting of a main important a node like this. We have a node that is called as a root node. Like take an example. This is the root node, and we have a left and right subtree. So we have on this side, we have a left node, or we can have right, the maximum. Only these three. So apart from this, we cannot have anything. Both subtree are themselves binary trees. So this also binary tree can define. So this cannot have 3. This cannot have 3. It can have 1 or it can have 2. So that is what we call as a binary tree. Normally binary tree consisting of 3 things. One is a root node, and we have a left subtree, and we have a right subtree. So even left subtree should be 2. Any nodes in the tree have at most 2 children. Every node maximum can have 2 children, or it can have 1, but never more than 2. Such collection of nodes or such trees are called binary trees. So now let us learn the importance of binary tree is that it can create a data structure that mimics S or no decision making process. You can see here, this is a root node. Traversing, we use this one. How, should I move to left? Yes, you can move. You want to move left or right? Yes, means you can go like this. You can traversing like this. Or yes, first itself is false means we go here. True means we go this side. Or we can go for left side. That's why it is used for traversing a linked list. Maybe when you have an expressions, the order precedence of operator, like we write A plus B, all are same precedence, doesn't make them. So if I have like this means how this is represented means we use a tree. So what is the first operation we are performing? Left, right. So this is first is A. That's we are performing plus operation. So left of this we have A, and then right of it we have a B. Okay. Then we have C plus C. So then we have one more operator. Right side we have a plus, and right of this we have a C. So when you go for in order traverse A plus B, and then we do not have left, and then we have a root node plus C. So this is how we are going to represent. Anyhow, we are precedence of operator in order traversal, post order traversal. We'll be learning in higher studies. This is a simple example how this infix notation can be represented. So left subtree, that is we have a root node, root, left, right subtree. For this we do not have a left. This whole thing is a left thing, so that's it becomes a right. So right of so in order traversal means we write left root in order first between the operators. So A plus B. Then what we go? So then we do not have a left. Say we don't have. Then we have a plus. Then we have a C. This is a simple example how trees are used to represent in order expressions. The evaluated expressions we may use in the future. Anyhow, that's something about let us learn about what is a root node. A node at the top of tree, the one from which all operations on the tree commences, is called the root node. The root node may not exist. If there is no root node means such trees are called a null tree or tree with no nodes in it. Or we have a degree 0 or 1 or 2 children in a binary tree. If exist, there can be empty tree is an example of binary tree, or it can have at most 1 or 2 children in a binary tree. This already we know. A node at the bottom of the tree the farthest from the root node. So from the root node to the last node is called leaf node. So leaf nodes have no childrens. So that's also we have understood. What is complete tree means? A tree in which each leaf node is at the same distance from the root node. That is, all the nodes have a maximum 2 subtrees. Such trees are called complete binary tree. So what is complete binary tree means? Each leaf node at the same level or the same distance, that is, we have same height. They are called as a complete binary tree. All the nodes have a maximum 2 subtrees. So though they cannot have more than 2 subtrees, that's a binary tree. What is the height? So number of nodes which must traverse from the root to reach the leaf node of tree. That's already we have told. That's something you must start from root to leaf is called height of the tree. Next we have one more. I think when you go for higher studies, you have a very interesting topic, this binary trees. And trees are very important, traversing, searching, all those operations what we discussed could also be performed with this. But this academic we are not learning, just we giving a introduction to this topic. That's why we have a nonlinear data structure. These are some basic definitions we have mentioned here. So next, learn about a graph. So another example, another nonlinear data structure is graph. What is graph? How this graph is represented? So graph is a set of vertices and edges. So we have like this. This vertices we call, among them we are connecting using a link. Don't think like data structure. So this is a graph. This line is called edges. So you can see a graph is a set of vertices like this, collection of many things, and edges. There are many things. You can connect one more here also. And this could also connect to this like this, and this could have one more like this. This can connect this as well. So this is something about called as a graph. So let us learn about and the connections between them called edges. So when you are connecting these things are called edges. So these lines with arrow represents edges. This represents vertex or collection, it's a vertices. So undirected and directed graphs. So let us learn about different types of graphs. One we have undirected, another is directed graphs. So when the edges in a graph have a direction like this, so that is called, the graph is called directed graph or digraph. And the edges are called directed edges or arcs. You can see here directed edges I'm using. So it's an example of what we call directed graphs. So neighbor and adjacency. A vertex that is an end point of an edge is called neighbor of the vertex. And that is this, it is starting point. The first vertex is said to be adjacent to the second. The following diagram shows the graph with the 5 vertices and 7 edges. The edges between A and D and B and C are pairs that can make bidirectional connection, represented here by double-headed arrows. So you can see this is the vertex and it is connected to B. So this is called neighbor, adjacent node. So this also, D is also adjacent. For D it is E is adjacent, neighbor, and this is neighbor. And you can see here, this B and D can move both direction. So B is also A, B and C or bidirectional. So we can have A, D, and we have a B, and also we have a C. They are bidirectional. We can traverse like this also, and we can go back to this also. You can reach the next adjacent and you can come back. But this one is from A to B is a unique. So you can go like this, but you cannot go back. But this you can go, and this you cannot go back. So that's a directed graph. So this is how the graphs looks like. And then we have this is a simple example. That's all there. Even you have a graph, so when you go for engineering or higher studies, you have a complete one textbooks for graphs. So that's one of the important topics in a computer science that you are going to learn. Whenever we learn pattern matching or artificial intelligence, we use the finite automata. They're all, we use this graphs. Graphs is one of the most important data structures that we'll be using in a computer science. Anyhow, so this completes data structure part. So where we started with the linear data structure. What is data structure? Then we studied about linear data structure. Then we studied nonlinear data structure. Then we talk about what is linear data structure. So what are the operations we can perform with the linear data structure? And one example for linear data structure, we started with arrays, stacks, and then we learned about queue. Then we learned about the linker list. And also I told about the linker list. There is some topic I was supposed to be explained, that is the stack representation of linker list. Stacks and queues, I told this will be I'm explaining when I explain data structures linear, because the dynamic memory allocation we are not familiar, we forgot, so therefore let me explain that. Okay, can we come into this? I think it's a stack now. Representation of stack using linked list. I supposed to explain. Okay, these are applications examples. We'll come back to this. So one is using arrays. This one we have discussed. And the stack could also be linked list representation of stack. So what does stack means? So ordered collection of element where insertion and deletion takes place at the same end. It follows the principle of LIFO, last in, first out, already we know about. So how do you represent linked list? That's a dynamic memory allocation, linked list representation of stack. The size of array needs to be fixed, already we know, that's a static data structure. The items into the stack. So if the stack is full, we cannot insert an additional item into the array. So it gives an overflow, that's a drawback. But in a linked list, so we can increase the size at runtime. That's a dynamic memory allocation by creating new node. So it's better to implement stacks data structure using a linked list. So linked list data structure, the linked list structure will be studied in detail. Now that's we already studied. You can see here. So this is the linked list. So we have a first node, we have a second node, and we have a last node. Actually, what happens means, so this will be the top pointer. So top pointer is pointing to this one. And this is the last inserted element. We start like first this node, okay. And then we insert as the beginning. This is the second element in the list. And that will be the recently inserted element. And top pointer will be here. And then next element we are inserting. So this is the recently added element. So there we have a start pointer as usual, and pointer top will be here. Okay. So already is there, just I wrote to understand how this is written, means starting from inserting each node at the beginning. So insertion operation refers to inserting an element into the stack. So we can create a new node and insert an element into the stack. To follow the stack principle, last in first out, a node need to be created from the end of the linked list and element need to be inserted into the node from the end of the linked list. You can see here we have a start, we create a new node and we insert as the beginning. So we have you can imagine this is the first node we have inserted, and this is the second node we are inserted, and this is the last node we inserted. You can create one more new node example, and then this is connected here, inserting at the beginning. This may be 60. And this has a link here, address. And the start is connected, so inserting node as the beginning. So now this is the recently inserted element. If you want to delete means you delete the first node. That's how deletion operation is performed. So deletion operation is to delete the element or node from the linked list. So deletion can be done by directing the topmost item from the stack as it last inserted. Is the first item needs to be deleted as per the stack principle. So the recently inserted item, that is the top item, must be deleted from the linked list. Perform this task, we have like this. We have the first element and this will be removed and it will be connected to the next node. That's how we perform the this is the recently added element. So just you delete means dislink this one, that's all. We connect start what we had link here, the start is connecting. So there we connect, this is delete. You want to delete this node means then make the start is pointing to here. So this is also deleted. So this is, you want to delete means, I think delete operation you already known about the linker list. This is how we represent stacks using linker list. That's how we perform input output operations. And we have one more is a queue. For queue also we use a linker list. Exactly similar, but it follows opposite and first in, first out. Where we can take a so linked list representation of, so it is a stack representation, and also we have a linker list. We have a circular linker list. It's also exactly similar. Okay, if you want, you can read. So you can see our memory representation. There you can see it's a linker list only. We have arrays we are discussed. Similarly, we can have a linker list. So we have a front and we have a rear. So this is where we are deleting, this is where we are inserting. It's exactly normal linker list concept. We have a head, that is a start, first node, second node. And this is where we elements are deleted. This is where the new elements are inserted, that's all. This is a queue that we call as a rear end. This is we call as a front end. Remaining is same. You know how to insert, create new node, attach here. If you want to delete, just remove this one. Insertion deletion operation we are already known. So this is how the linker list could also be used to represent dynamic memory allocation. That is the advantage, same advantages. So static arrays are static. This is a dynamic structures. I think we have understood this data structures, and if you have any doubts, prepare the complete notes for the data structures, and I want the handwritten notes. Keep this very important, and you have to study well. When you come, classes starts, I'll check the complete notes. Okay, we'll continue next class.